So this section actually does not exist in your book, but it's a section that was in our old book, and I think that it's important because it does come to play later, and they actually kind of just expect you to know it. So since they just expect you to know it, I decided to just kind of start this chapter out with it, so that way we can all be on the same page with it, so that way we know for a fact we know about the mid-segment. Because if you don't know about the mid-segment, it's going to be kind of a challenge later on. All right? So there is this word mid-segment. Okay? You should be able to come up with what a mid-segment actually is just based on the word mid-segment. Mid means middle, and segment means line. Okay? So if you hear the word mid-segment, which you think of as like middle line, most of you could probably draw that picture on this triangle, because it's a line that goes through kind of the middle of the triangle. All right? So a mid-segment of a triangle is a segment that connects, any guesses? A segment that connects the what of two sides? Any guesses? Has to do with the word mid.
Midpoint?
Midpoint of two sides. Now it doesn't matter which midpoints you're talking about. If you're talking about this midpoint right here and this midpoint right here, it doesn't matter which one you're talking about. You could be talking about the bottom one as well. Doesn't change anything. But a mid-segment is the line that connects the midpoint of two sides just like that. Okay? Now, I'm just going to draw this next part in a different color so that you can see it. Like this. And then I could also connect this point to this point. And I could also connect this point to this point. So how many mid-segments are there in that one triangle MID? 3. There are 3 mid-segments in each triangle. So every single triangle has 3 mid-segments in it.
So you're just making like a triangle and a triangle pretty much?
Pretty much. Yep. Okay. Now, I'm going to name these E, F, and G. And now when I label these, I'm going to try to make the color go along with it. So my first one is EF. So one of the mid-segments of this triangle is EF. One of the mid-segments of this triangle is EG. And one of the mid-segments of this triangle is FG. So the way that I named them, E, F, and G, I'm just showing you how I would name those mid-segments in a triangle. That's what a mid-segment is. Now the thing about this is the mid-segment has a ton of things happening with it. A ton. Okay? There are a bunch of things that go on with a mid-segment, and all of them come from this thing with a mid-segment. Okay? So, what I want you to kind of understand is this next theorem is going to have a bunch of different like traits about it that will then apply to every single other one of the mid-segments. So if it's true for one of the mid-segments, it's going to be true for all of the mid-segments, and it's going to make our triangle look crazy, right? So it's going to make this thing look nuts. So the way that this segment, or the way that this theorem works, is the mid-segment of two sides of a triangle. Okay, so the mid-segment, so like this thing right here, see how there are two sides coming together, and the mid-segment is connecting this side and this side right here, and this side right here. So the mid-segment is connecting those two sides of the triangle. What does it look like it is? If you had to make an observation about that, what does that side look like it is? What would you say about it? What would you say if you had to look at it and guess something about it?
Well, about that triangle?
Of that line. So you're on a game show, and they said, answer something about this, and you win money. What would you guess? You wouldn't sit there and stare at it like you're staring at it right now.
It's in the midpoint from the triangle.
Yep, it is the midpoint from side to side. We've already got that. We're looking for something new. Someone guess something. Literally anything is better than nothing. Okay, that kind of goes along with midpoint, so that's a good guess. But what Will is saying there is he thinks it's about the same distance from here to here as it is from here to here, which is true. It is the same distance from there to there to there to there. What else? Guesses, people. Guesses. Brain inside heads. Show me that you are living.
So, you know that one thing where the inside.
Are you thinking like alternate interior, alternate
Yeah.
exterior?
Yeah.
Yeah. What does alternate interior, alternate exterior, consecutive exterior, what does that have to do with? What did that have to do with? What did two lines have to be in order to use those things?
Parallel.
They had to be parallel.
And those two lines are parallel.
That is correct. These two lines are parallel to the third side. Those two lines are parallel, which means this side and this side are parallel to each other. Okay? That should only be one line. So those two lines are parallel to each other. Any other guesses? I'm going to kind of doubt it because you guys are just sitting here staring at me. Any other guesses? It says that and blank as long as that side. What would your guess be if you had to finish that statement? It is parallel to the third side and blank as long as that side.
Equally as long?
Is it equally as long? Is this thing right here equally as long as this side?
No.
How big do you think it might be?
It might be less.
How much less?
Like half.
Half. As long as that side.
So why would it be half?
Think about it. Midpoint connects the middle of two things. Middle splits something in half. So if it connects two things that are half and half, it should be about half the length, right?
Okay.
Right? So that what that's saying is that this side right here is half as long as this side right here. So if I were to take two of these together and put them together, it would equal that third side. Okay? Which means that I could put a midpoint right in here, and all three of these lines would be congruent to each other right there. All three of those lines would be congruent. Okay? Yes?
So, how would you be able to find the Midsegment Theorem? How would you be able to go through that?
So first off, you are going to be told that something is a midsegment. Or you're going to be told that something is a midpoint. Or you are going to be told that something is happening to the triangle. Very rarely will you have to create the midsegment. You actually likely will not have to create the midsegment. It is going to be created for you. Okay? So if we look at the next part, if we look at this next part right here, where it asks me about this stuff, and it asks me about this midsegment, this has to do with the fact that the midsegment is half as long. So right now, if you notice, this is exactly how these questions are going to look. It tells you that MP is a midsegment. It tells you that. It says that it is a midsegment. And if it is a midsegment, then what we're going to do is we are going to be able to figure out other lengths that have to do with things. So now if you look at this, I know that this point right here and this point right here are midpoints, which means that they are going to be equal to each other. These sides are all equal to each other. This is just something that you should know every single time that you see a midsegment. This is just common sense at this point, or it has to be.
Yep.
So when you look at this, it just has to be common sense when you look at it. You have to say, oh, I know that if that's a midsegment, all of those sides are the same. The other thing that you know about the midsegment, based on the fact that it's half as long, is that this side is half of this side. This side is half of this side, and this side is half of this side. Those are things that you have to know just based on looking at the picture.
You will find the X for that. You just half of whatever the big one is. So if that's 16, then it's 16.
So this would be half of 16, which is 8. Okay? How big would this side be? I hope somebody says it.
You just pointing at the X.
I am. How big is it?
Hello? Say how many
Well, that's equal. It's on.
You don't
I
think-
think it would be 14, right?
Now, Blake, you gotta think here.
Are you just taking half that 7?
I don't know. Are you?
I don't know. We're taking half the bottom line, but there's no number in there.
Yeah, that's it. But there was no number here, and you still figured it out.
What do you mean? This is 16 right there. What one we're trying to figure out?
There's no number here.
Yeah, okay, you took half of 16, did you
Correct.
not?
That is correct.
Okay, so pretty much you're taking half of 7.
Okay, so what Blake is saying is that this should be 3.5.
No.
I don't know. I'm just,
So I want you to think about this. I don't know how you're so worked up about the fact that there's
I
an
know.
X there, Blake.
I
So
feel like, I don't know.
there's a 3, so Blake is saying 3.5. Now that was the problem, or that was the thing that I was hoping that somebody would say, because I guarantee it's going to become an issue later on. Guarantee. Is that side 3.5? Whatever the units are.
No.
Why not?
Because it's obviously bigger than
Right. It's obviously bigger than the midpoint. The middle one is, right? So that means this is where I always say in geometry, you have to do something called check for reasonability. You have to check to see if your answer is reasonable or not. And so that was perfect what Blake did, because he knows the actual answer. He just said 3.5 to test you guys. Right?
I know the answer.
He was just testing to make sure that you guys could understand that this can't be 3.5, because if this is 3.5, it would end up being smaller than 7, and that doesn't look like the picture. That can't physically happen. So Blake, what is the real answer?
14.
It is 14. See, Blake knew it all along, and he was just testing you guys, and you guys didn't catch it.
Well, I just think that will.
He was trying to catch it for you. All right, what's X in the last one? Any guesses?
4.
4. No, actually half of 4.
No, it's 4.
It would be 4, just 4.
Yeah, it has to be 4. So that's like the piece of the midpoint in that line.
Correct. So that piece is the midpoint, which means that if one side is 4, the other side will also be 4.
So is this like, is this like the whole chapter just trying to find what X equals?
Yeah, mostly. You might have to prove a few things here and there, but for the most part, it's going to be solving for X. Now, this is a picture that is very, 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 very important. Okay? Because what I'm going to do is I am going to mark everything that I know on this picture if I know that DE, EF, and DEF are all midsegments. Now, this is important. Okay? This is an important concept. So what I want to do first is I want to talk about the angles. We already kind of know about the sides, but let's talk about the angles. This side and this side are parallel to each other, right? And if I know that those two sides are parallel to each other, and I know that I have a line going like this angle right here and this angle right here are corresponding angles. I can do the same exact thing with this line right here, because I have two parallel lines and a transversal, which means that that angle and that angle are corresponding angles. I could do that all throughout the triangle. Okay? So if you want to see me break down every single one of those parallel lines, I can break down every single one of those parallel lines, and I can tell you exactly which ones are congruent to which because they are corresponding angles. You can do this with every single one of these, and it doesn't make a difference. They're all the exact same. Okay, they're all corresponding. I can go like this and have an angle down there and say, oh, that one is corresponding with this one. So you can say that all of these angles are going to end up being congruent to something else. So what I'm going to do, if you're interested and want to see exactly how they're congruent to each other, I can break it down and walk you through that. Most of you don't care about that though, and you just want to know what it looks like. So we'll go through that. So these are the angles that are congruent to each other, and I'll try to make all of the ones that are congruent to each other the same color. So this angle right here, this angle right here, this angle right here, and this angle right here are all the same. Those are all the same because of corresponding angles, or alternate interior angles. So if I were to do this line, and this transversal, this line and this line, or this angle and this angle are alternate interior. Yes.
So couldn't you say that E, J, and F are the same? Because they're like the same as D, E, F, right?
So I'm still not done. I've got more angles to go. But yes, technically, I don't really know what you mean when you say E because there's 3 angles at E. So I don't know what E means.
No, so like the triangle D, E, F, and then I'll give it another triangle within that. I'm going to be the same. They're both the same, they're both the same angle, right?
You could technically, yeah. Yeah. So this angle right here and this angle right here are all the same, which is the same as this angle, which is the same as the same. Okay? And then finally, the last one is, this angle, which is the same as this angle, which is the same as this angle, which is the same as this angle. Those are the angles that are created because of a midsegment theorem. Now, what I'm doing when I'm putting those marks there, if you don't remember those marks, everything that has 1 mark is the same. Everything that has 2 marks is the same. Everything with 3 marks is the same, and everything with 4 marks is the same. So on and so forth. But you can see that all of those angles are the same, which means, basically, this triangle is the same as this triangle, which is the same as this triangle, which is the same as this triangle. This one's just flipped upside down.
I'm sure that's what I was trying to say.
Was it? Okay. So these 4 triangles are all the exact same. And if they're all the exact same, then that means the same exact thing with the sides. Remember, D was a midpoint, which would mean that that side and that side were the same. E was a midpoint, which means this side and this side are the same. And F is a midpoint, which means that these sides are the same. And now remember, this is where the midpoint part comes in. This is where that midsegment part comes in. This side right here is the same as this side right here. This is half of the whole thing down here. So this is equal to this, which means that it will have 3 arcs. This is equal to this. You can actually see it, right? Those are the same, which means 1 mark. This is the same as this. So these are the same as each other, which means this one is 2 marks. So you can now see how crazy this picture gets just from having a midsegment.
Yeah.
This is why this is tough. So this is why I'm suggesting to you very, very strongly that you really pay attention to what a midsegment is right now, because we are going to learn 5 different types of triangle things that can happen like this. This is number 1, there's 4 more. So this is number 1, there's 4 more that we're going to end up learning throughout the course of this chapter. 5 total. This is only one of them, which means that there's 4 more confusing things that can be thrown at you. So if this seems to make sense right now, make sure you don't forget it. Make sure you just keep thinking about it so that you understand what's going on. Okay? All right, let's go through a couple examples together, and then I'm going to give you guys some time to work. When I say we're going to go through some examples together, I'm saying I want to go through like this, and I want to see if you guys can do this.
Okay.
Okay? And then we'll go through that one together. But I want to go through this together right now. We'll talk about that first. And then after we get done with that, I want to see if you guys can take care of the big triangle yourself. Now, that picture that you just drew, use it. It's important. Use that picture because it might help you in the future. Okay? So GE is this one right here. Right? GE is this one right here. If you want to, you can mark up this picture. You can put a mark here and here and here, 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 here. You can mark up your picture. It should become second nature for you to mark up that picture because you should be understanding what midsegment triangles look like. Okay? So, if GE, it says, is 8. Let's go through. Why don't you guys try it? Why don't you guys try it first? See what you can do. I want to see if you can get it because I think most of you will be able to. So, any easy ones that people were able to figure out quick? Anything that people were able to see, understand, think about, know, understand more, further? DG was easy. What was it?
8.
Okay.
Mostly everything was easy.
Okay, so what was the easy ones? Tell me what the easy stuff was. What was DE?
DE is 16.
Okay. Did you get KJ?
That was a difficult one. That was kind of difficult. I put 10.
Okay.
But I know
So
for sure.
put a question mark right there.
And
Did you know
then
GK?
GK.
Oh, GK was easy.
Yeah, that was easy. I put 10.
Okay. EF?
EF. I put 16. Because.
Question mark there.
Well, no. Why is it not 16? Because when it. So that one line, GE, that equals 8, right?
GE, that equals 8.
So what does EJ also equal 8?
No.
Why would that
Because
not?
it shows you on the picture they're different. This one has 1 tick mark, this one has 2 tick marks. So they're different.
Oh, they are different.
Mm-hmm.
Okay. Well, EJ's then wrong.
Okay.
and then JF is also the one.
Okay, so did you get DF?
Yeah, that's 24.
Did you get DK?
12, and then KF is 12.
Okay, did you get GJ?
No, that was the last one I was like, figuring them out.
Yeah, Brady.
KJ is 8.
Okay. Didn't sound like there was a question mark there, so I'll just write it down.
How's it 8?
I don't know, we'll talk.
EF is 20.
Okay.
EJ is 10.
Okay.
GF is 10.
Okay.
And then GJ is 12.
So I will tell you right now that Braden is absolutely correct with that. Everything that he put down is absolutely correct. And the way that we think about this is, first off, you can look at this, and the way that I marked up the picture, you should be able to see that every single thing that has one tick mark is 8. You should be able to see that from the picture. So just based on the picture, this is 8, this is 8, and this is 8. That's just based on the picture. Everything with 2 tick marks is 10. 10, 10, 10. Everything with 3 tick marks down here, well, if this was 24, and this one was 12 right here, then everything with 3 tick marks would end up being 12. So DK, KF, and GJ were 12. Okay? If you didn't see that or didn't understand how that worked, even if you didn't have these marks down, it's still possible to figure it out because of the midsegment theorem. If this is 24 down here, this is half of that. It was easy, as Blake said, to figure out that this was 16. If this is 16, this is half of that. This piece right here is half of EF. If 10 is half of something, 10 is half of 20, so EF would be 20. Okay? Easiest way to do this by far, though, is to write the stuff down in the picture, draw the marks on the picture, and once you get the marks on the picture, just try to translate it as much as possible. Okay? I'm going to leave the next one for you, and I just want to kind of talk about the back to make sure we're okay on the back to know what's going on. All right? These are tricky. This is algebra. This is going to be one thing that we pick up tomorrow, but I want you guys to at least try these things tonight, and I want you to give it your best shot so that way we can come in tomorrow with any questions that you guys have. All right? So all it is setting up an equation based on the picture that you have. All right? All this is setting up an equation based on what you've got with your picture. Now, every once in a while, we might have a hard time answering these questions because we might have a hard time picking up the problems. Now, if you think about this, we know that this side right here is a midsegment, right? And a midsegment is half of the side that goes with it, right? So that means that 2y plus 13, or 2y plus 3, is equal to half of 26. Does that make sense how I came up with that? I just used my words, and instead of actually saying the words like side is half of side, I just put in the algebra. So this side was 2y plus 3, and that equals half of this side, which is 26. So now when you solve this, you get 2y plus 3 is equal to 13. And then it's just an algebra equation to solve from that, which I hope that we can do, right? So when we solve that algebra equation, we subtract 3. So we get 2y equals 10. Divide by 2, divide by 2, so I get y equals 5.
Well, I didn't forget y was 5 out. Is it important for later?
No, it just asks us to solve for x and y. At the top of this page, it should say solve for x and y. Okay, so that's what we do for y. Now, can anyone think of an equation that we can do for x? Any equations you can think of?
Can you plug in 5?
You cannot plug 5 in for x, nope.
I think that's because now that problem says divide
Can't you-
under 23 by 4.
Nope. Yeah, but
Can't you just do 4x minus 23 plus 5?
Yep.
And then you add 23 to both sides.
Mhm.
And then 4x equals 28. And then divide by 4, and that would equal 7, I think.
So you just have to figure out what pieces are equal and then say that they're equal with the algebra behind it. Okay? So what I want you guys to do tonight, and actually today because you got 7 minutes, I want you to try the rest of these 5 algebra problems. and I want you to try the big picture on the front. Start with the big picture on the front. Okay? Start with that big picture on the front because it's got angles in there. It's got sides in there. Use the picture that we drew that you have the little box around that has all of the important information. If you have to mark up that picture at the bottom, mark up the picture at the bottom. Okay? Take your time with it and try to figure out what's equal to what, because that is all of the battle with Midsegment Theorem.